Dinosaurs are one of the most spectacular groups of animals that have ever walked on planet Earth.
Their size, their varied shapes, and their history have inspired generations to take an interest in natural history. But knowing their evolution makes them even more incredible. Rarely in history has a group dominated ecosystems so successfully. Today, we will dedicate ourselves to knowing the main groups of dinosaurs, with dozens of iconic species and their kinship. We will trace a timeline of the era of dinosaurs and know what the world was like in each period, as well as the main events that marked the Mesozoic Era. We will see how they took the world for themselves.
From their humble beginnings to their catastrophic end, 165 million years of evolution molded them into many different forms.
What makes dinosaurs unique? How did they arise? Who were their ancestors? How was the world they inhabited? Why did only one group survive the extraterrestrial impact that marked the end of the Mesozoic? These and many other questions will be answered in this documentary as we explore the Mesozoic Era. You are about to dive into deep time to know the evolution of the dinosaurs. To begin our journey, we need to locate ourselves in time. The Mesozoic Era is subdivided into three periods: the Triassic, the Jurassic, and the Cretaceous, each with its unique cast of animals and plants. This era begins about 251 and ends 66 million years ago. Although this seems like a long time, it represents only 4% of the total duration of the history of our planet. In perspective, the first dinosaurs would appear at 10:46 p.m., and we humans just over a second before midnight. At the beginning of the Triassic, there was only one large continental mass, the famous Pangaea, which housed in its interior the largest desert in the history of the planet. The world was recovering from the most profound extinction of all time at the end of the Permian, which eradicated more than 90% of species, when conditions became more favorable for life. Biology responded with an explosion of animal and plant diversity, with many new creatures ready for the challenge of occupying this dry, wounded, and empty world. By the end of the Cretaceous, the world was fragmented, with more than 7 large continental masses, meaning the world map underwent profound transformations. This made this era an extremely active volcanic moment in the history of our planet. And as we will see, volcanoes played a fundamental role in the evolution of the dinosaurs. In the past, we believed that the Mesozoic Era had been so hot that no ice could form. Today we know that although permanent ice shelves did not exist, during the winter, temperatures could drop, especially in the coldest moments, like the Middle Jurassic, when the climate resembled the current one. But the dinosaurs arose in the Triassic, in a moment of extreme heat and very low oxygen. Probably about 12%, half of the current 21%. Investigating how life responded to this climate is how we will begin to understand what makes dinosaurs unique and how they conquered the world. Dinosaurs are defined by a common ancestry. This means they are a true group. That includes the common ancestor and all its descendants. That's why not all large reptiles are dinosaurs. They are more related to each other than to pterosaurs or crocodiles. They are one big family. Unique characteristics in their skull, limbs, and hips are shared by all dinosaurs, including birds. Among the most fundamental characteristics for their success, some stand out. One is bipedalism, walking on 2 hind legs, a habit that evolved independently only a few times in history. Unlike other reptiles that have sprawling legs,
forcing them to drag their bellies on the ground.
This allowed them to be agile and move efficiently to hunt insects and escape predators.
Another was their extremely efficient breathing in a unidirectional system that extracts oxygen constantly. Different from mammals, this system was inherited by birds, which have hollow bones and air sacs, making their body lighter and their breathing more efficient, allowing them to be more active and explore higher altitudes than many animals during the suffocating beginning of the Triassic. Furthermore, their metabolism allowed them to grow extremely fast, as shown by bone analysis, evidence that they gained a lot of weight in a short time. This metabolism was homeothermic. Like that of mammals, they were able to control body temperature, producing their own heat, allowing them to be constantly active even when it wasn't hot, but requiring much more food. To satisfy their immense caloric demands. All this indicates that dinosaurs were not slow reptiles, but active, fast, intelligent, and dynamic animals, which was a determining differentiator in their history. To continue exploring their history, we must understand how they are classified into two large groups: Ornithischia and Saurischia, which in turn are both divided into two large lineages. On the Saurischia side, we have the theropods, the famous bipedal carnivorous dinosaurs, which also include all birds, the only living group of dinosaurs, and the sauropods, the immense long-necked herbivores that became the largest land animals of all time. The Ornithischia are completely extinct, known for being mostly herbivores with bizarre body shapes. On one side, we have the Thyreophora, which include the stegosaurs with bony plates on their backs, and the ankylosaurs with wide hips and complex bony shields on their backs. On the other side, we have the Sauropoda, which include the duck-billed ornithopods, and the ceratopsians, famous for their horns and bony shields. This is a great summary, but it will surely facilitate understanding from now on as we address their emergence and disappearance. It's important to understand that not all dinosaurs lived together. Some groups lived for a long time. Others, not so much. Each moment of the Mesozoic had its specific cast of dinosaurs. Just like every place, since few species inhabited the entire planet, dinosaurs didn't arise immediately. The first of them appeared approximately in the middle of the Triassic, becoming dominant later. The fauna of the dry, hot, and suffocating Triassic world was a profusion of bizarre forms, mainly archosaurs, the broader group to which dinosaurs and crocodiles belong. There were archosaurs resembling bipedal crocodiles and herbivores with beaks like Iphygia, other carnivores with immense and disproportionate heads like Erythrosuchus. Not to mention the synapsids of the gigantic Dicynodonts, more related to mammals than reptiles. The Triassic period is probably the strangest and most experimental since macroscopic life invaded continents. Just like every place, since few species inhabited the entire planet, dinosaurs didn't arise immediately. When dinosaurs appeared, the world was no longer empty. They definitely had competition from all sides. This explains why the first dinosaurs are so rare and so difficult to be found. The first hypothetical dinosaurs looked a lot like a small theropod, bipedal, and insect eaters. This means that theropods were the group that most conserved this basal format evolutionarily. As we will see, all dinosaur lineages have an ancient member that resembles this body scheme.
About 245 million years ago, a very enigmatic group appears, the Coelosaurids.
These small and medium animals varied from insectivorous, herbivorous, and even carnivorous habits, and are found all over the world, having occupied Pangaea from north to south.
There is no consensus on their position in the dinosaur family tree, but two hypotheses compete.
The first is that they are not dinosaurs, but dinosauriforms, a very close group. The second is that they are basal ornithischian dinosaurs. If this is true, they are the oldest, more than 15 million years older than the first definitive dinosaurs. This is as strange as it is sensational. About 233 million years ago, in the Carnian stage, large climatic changes defined the fate of life. Submarine basaltic flows of continental proportions occurred where Alaska and Canada are today. The so-called Wrangelian flows heated the oceans and atmosphere like a large sauna, causing uncontrolled global warming and adding a colossal amount of moisture to the atmosphere. This was the Carnian pluvial episode, a moment when for 2 million years it rained abnormally, causing a pulse of change in fauna and flora that extinguished several bizarre lineages of the Triassic. The big winners were the dinosaurs. After the Carnian rains, they became common animals. To know the first animals that are undoubtedly dinosaurs, we need to look at South America.
Formations like Ischigualasto in Argentina and Santa Maria in Brazil present us with an exuberant fauna.
Staurikosaurus is one of these animals, considered one of the first dinosaurs, a Herrerasaurid. They may look very superficially like theropod dinosaurs, being bipedal predators of small and medium size. But they are not. They are older than theropods, becoming the first dinosaur predators in history. Herrerasaurids have a confused and complicated history of taxonomic classification, having been considered theropods,
or even not being considered dinosaurs, although recent analyses find them in a basal position in Saurischia.
But by far, the most common and diverse group of dinosaurs at this time were the sauropodomorphs. As the name suggests, they are a group more related to the sauropods, the long-necked giants.
But during the Triassic, they were exploring various modes of life, from insectivory to plant-eating.